everybody. The purpose of this video is to get you some solutions to this homework about margins of error. So we're just going to kind of go through them, 1, 2, 3, and whatever. The first two are wordy answers, not math answers. I gave you two scenarios where somebody does a sample of 100 high schoolers and says 25 of those 100 have ADHD, so therefore 25% of all high schoolers have ADHD. Second one has more money, more time, more ability to sample more people and does 1,000 high schoolers and gets 279 out of the 1,000. So he or he says that 27.9%, which is 279 out of 1,000. Neither's right. And I gave you some hints. I asked why, and then I asked you a couple questions. I said, hint, what would happen if, it says in, but if another statistician came along and did the same study? Well, you see how both of their numbers came up differently? That's because they're drawing a sample, probably randomly, of the population, which means that you're going to have slight inconsistencies. Kind of like in class yesterday and today, when I had you measuring things with stopwatches. You all use the same stopwatch, watch the exact same video, but yet every time you took a sample from that video, you got a slightly different number. Same as these statisticians. So to say that their number is the right answer is to ignore all of that variability, which we'll get to in a second. And then number two here was asking, give me one reason that directly measuring the parameter, the percentage of all high schoolers in America with ADHD would be darn near impossible. Well, quite simply, I can think of two reasons at least. Number one, if you started measuring right now, going to every high schooler in the country, you wouldn't be able to finish before next year when new freshmen come in and seniors leave. That's one reason. That's one reason. The other reason is, well, actually, that was both reasons. Time, I guess, because it would take too long. And number two, you would never even put a dent in the actual number you're trying to measure. So this is not a bad thing. It's a thing, but it's not a bad thing. It's a thing because we have to admit the fact that we'll never ever be able to get the exact number. But that's not what statistics is all about. It's not about the exact number. It's about bookending the number between two numbers and trying to catch it. And that's what margins of error do for us. So then this was just really quick examples back here. Suppose you have a statistic, and these are not related at all to the ADHD one. Suppose your statistic is 36% and the margin of error is 8%. So what you're going to do is 36% plus or minus 8%. So the smaller number would be this minus this, which would take us down to 28%. And the bigger number would be that plus that, which would take us up to 44%. A lot of you wrote it backwards. You wrote 44 to 28, and I should have made that clear. You write it lower to larger, but you'll figure that out in stat classes later. So instead of saying, I think the percentage is 36%, you more correctly statistically say, I think the percentage is somewhere between 28 and 44%. That plus or minus 8% gives you uncertainty, which is good. You have to be uncertain because if somebody else does the study, they're most likely going to get a different number. If you do a similar study on similar populations, you should get close to the same numbers, and the margin is supposed to make up for that difference. Suppose you have 3.4 hours and your margin is half an hour. And again, yeah, half an hour. So 3.4 hours plus or minus a half an hour. Okay? So if you go down, that's 2.9 hours. If you go up, that's 3.9 hours. Pretty straightforward stuff. And then I said write them in, what would the plus or minus form look like? So you had 15 pounds plus or minus 6 pounds. 15 minus 6 gives you 9 pounds. 15 plus 6 gives you 21, that kind of a thing. 12 hundredths of a watt plus or minus 1/100th of a watt. That would be down to 11 hundredths of a watt up to 13 hundredths of a watt. And then I gave you more of a verbal thing here. Because this last statistician is a good statistician, he also knows that 25%, that 25% has a margin of 10%. So he has to add and subtract the 10% to the 25%. So he says, I think it's between 15 and 35%. And I asked you first, how did he get those two values? Well, he did what I just said. He added and subtracted the 10% to the 25. Okay. And then the last one, hopefully you saw the pretty straightforwardness of the, which statement do you think is more likely correct? It's the second one, obviously. The first one's too specific to be useful at all. It's like saying, I weigh 185 pounds right now. I don't. I weigh around 185 pounds right now. I'm sometimes as low as 175, sometimes as high as 191. It all depends on lots of things, like what time of year you're checking me, how long has it been since I ate last, did I just ride my bike for 100 miles? All kinds of reasons influence my weight. If you take lots of samples, it centers around 185, but I'm not usually anywhere near exactly 185. I'm close, but not exact. Cool? All right, hope that helps. We'll see you in class. Did you stop?